All right, we are going to be starting a new unit today. And in this unit, we're going to be talking about being able to find the measurement of segments, and we'll start getting into angles and angle pairs. And eventually, we'll even start talking about how to prove relationships between angles and segments. But we're going to start today in this first section of finding the length of segments that are maybe missing from a picture. Now, when I say find the measure of a segment, I don't mean we're actually going to be measuring segments here. What I mean is that we're going to be given information about a potential segment that's out there, and they're either going to give that to you in words or they might give you a picture. And we need to set up equations using the parts of the segment that we know or what we don't know and being able to solve for whatever they're asking for. So I would recommend all the time when you guys are doing these kind of problems, if they don't give you a picture, that you should try to draw a picture, because it helps us see what's happening instead of trying to visualize the picture, try to place these points that we're being given mentally in our heads, because sometimes we can make mistakes if we're not being extra careful with paying attention to the information that they give us and what you're looking for. Before we get too far into it, there's one vocab word that I want you guys to just write down, and that's just going to be here at the top. And this word that I want you to write down is called collinear. Collinear kind of sounds like the word linear that we've seen with lines, which makes sense if we're talking about segments that would come from a line. But it also has this prefix co in front of it. And so if you think about other words that start with co, like cooperate or communication, like those kind of words, that prefix co means together. Like if you're going to cooperate or even collaborate, those both mean that you're going to be working with other people. If you're communicating with someone, you're communicating or you're working together or you're talking together with someone else. Linear, like we said, means lines. So when we have the word collinear being put together, this means that we're talking about things that would be working together on the line, specifically points. So I'm going to say for collinear that this would be when you have a bunch of points that are on the same line. So sometimes when we look at problems today, they're going to tell you, especially if they don't give you a picture, they're going to tell you, hey, points A, B, C, D are collinear. And so that just means they're all going to be on the same line. That way we know when we draw our picture, we're only working with one big line segment instead of working with a bunch of tiny pieces. So sometimes with these problems, like I said, they might already give you a picture. Like these first two are already providing us with pictures of these line segments. And they're going to have some information drawn on the pictures for us. You'll notice on a lot of these that they'll have these arrows kind of underneath or maybe even above the lines with maybe these like kind of dashes on either side of the arrows. And that's just trying to tell you from this point to this point is this much. So on this first picture, D to C, see how they have the 10 written right above that. So that's just talking about the length from point D to point C. Underneath that, with the blue arrow and the 16, that is going from point D to point B. And then even underneath that, from point E to point B, they're saying is 26. Okay, so being able to kind of understand that notation so that you know what they're describing or where those numbers go or what do they mean in the context of this problem is important. What I want to do is figure out the length of E to C. So on my picture, I want to know how far it is from here to here. That's what I don't know. So let's take a look at what we do know. If I can, not everything is filled in with numbers, but maybe let's see if we can figure out anything that they're giving me. So I'm going to start with that 16 because that's from D. So that's from here to here. They're saying is 16. Well, we know part of that is 10 from the picture. So how much would this other little piece be? Right, 6. Okay. So now I can think about the bigger picture because they told me also down here that all the way from B all the way to E, they're saying is this 26 down here. So that's the entire thing. But you're given that these other pieces, the 10 and the 6 together, kind of make up the right side of that picture. And all I need right now is to figure out how much this is, E to D. So if the whole thing is 26, and we know that these two parts on the right are 16 together, how much would that leave for this little piece? It'd be 10, right? So I'm going to add this kind of up. I took 26, and I took away that 10 plus that 6. So I took 26 minus 16, which would leave me with just 6. Okay, so let me clean up my picture a little bit here because I've kind of scribbled all over it. So I know that this is 10, this is 10, and this is 6. Okay, I now know all those little pieces, but I'm not quite done because remember, what did they ask for? They wanted E all the way to C. So now I just need to look at these parts of the segment, which I know now are both 10. So to find EC, I'm just going to add 10 plus 10, and I would get 20. If you look at number 2, it's a little bit different because they're not just giving you numbers like they did on number 1. Number 2, we have these portions again, but they do have variables being thrown into this one. If you think about the picture that we have on number 2, they're asking me to figure out how long C to E is. So what is the length of the entire segment here? But when I look at how this is drawn out, it's kind of split into a couple of different parts. And each part, if I put them together, should get me the entire segment. So up above where it says 12 and where it says 2x plus 40, if I were to stick those two smaller pieces of the segment together, it should give me the length of the entire segment that I have there in my picture. So I'm going to try to write this out so that it looks like an equation. What I just said there is that the 12 and the 2x plus 40, if I were to put them together, and how do you guys think I would be putting them together? I'd probably be adding them together since they make up this whole segment. So I'm going to write 12 plus 2x plus 40. And what do you think I'm going to set that equal to? Yeah, the x plus 38, the entire thing. Okay, because when you have those points, they're still all on the same segment. They're just maybe breaking it down into these smaller chunks. And so when we're trying to maybe combine them, we're going to add the smaller pieces together, and it should be equal to the entire thing. Okay, so now I've got an algebraic statement here. Okay, so all last year when you guys were in algebra, you spent a lot of time working with things that looked like this, where you guys were putting numbers together, putting x's together, trying to figure out what the value of x is. So you're going to have to kind of think back on your algebra days, pull those skills back, okay, and we have to apply it to this problem. So the first thing I would do is look for any like terms on the either side of the equal sign. So I see a 12 and a 40 here, so I'm going to put those together. I'm going to rewrite this so it says 2x plus, and that would be 52 together, equals x plus 38. And now we need to start combining the other terms. And this is when you have to start moving things around the equal sign. So remember, whatever you do to one side, you have to do to the other side. Okay, so I'm going to start by getting my x's together. And I always like to think about keeping x positive. So I'm always really mindful of when I'm moving my x's that I want to make sure it stays as a positive number if I can. It's not always able to be done that way. You sometimes can't avoid the negative, but if I can, I'm going to. So for this one, I'm going to move this x that I have over here on the right over to the other side by just subtracting it. So that gets rid of those over there, and I'm going to simplify. Now 2x minus x is x. I bring down the plus 52, the equal sign, and the 38 drops down as well. What would you guys do next? Subtract 52. Good. Okay, I'm going to squeeze this in over here. So if I subtract 52, I'm left with x, and then 38 minus 52. We get negative 14 here. Okay, so let's stop for a second. Are we finished with this problem? Have we found what they asked for? Okay, think back. They wanted us to figure out what? The length of CE. Have we done that yet? And we have x, but I don't think that's our final answer. Like x isn't where they wanted us to stop. We need to now take this number and we got to plug it back in for CE. Now, CE is made up of these two parts, the 12 and the 2x plus 40, or we're thinking about it down here, it's that x plus 38. So you've got a couple of options here, but you're not quite done. You have to take that negative 14 and you have to plug it back in order to figure out how much it is. Now, you could plug it in two different areas. You could plug it into this 2x plus 40 and then add that with the 12, because you could take those two smaller pieces, put them together. The other option would be to plug it into the bottom, since you know that x plus 38 represents the entire segment. And so if you do that, it would be negative 14 plus 38, which would leave you with 24. So that's CE. That's your final answer. So something I want you to be aware of here is when you're solving these problems and you are trying to figure out how long a segment is, your segment length should never be negative. Now, I got a negative number for my x value. That's not a problem because I have to take that and plug it back in. And when I did, I got a positive value for my segment. So that's just something that you can kind of just be aware of when you guys are doing these problems on your own. If you were to ever solve for the length of a segment and you get a negative number, you should probably go back and reevaluate what you did. Because if we were measuring something, we're not going to measure something negatively. We can't do that. If I wanted to measure the dimensions of this room, I don't have yardsticks or meter sticks or anything like that would have negative numbers on it. So when you guys are doing problems with these segments, you shouldn't have a negative final answer when you're looking for the length of a segment. It's okay to have a negative x value as long as when you go plug it back in, it's not giving you a negative answer for your segment length. Okay, so just keep that in mind. All right, these bottom two here are very similar to each other. So we're going to do one together, and then I'm going to give you guys time to do the other one on your own. But again, notice how in the directions, they're giving you some information, and they're doing that because look at this one. There's no picture that's being drawn. And if you remember what I said at the beginning of this lesson is I said I would draw a picture that kind of illustrates what's going on. And if you read the directions here, it says points A, B, and C are collinear. Remember we talked about that. Collinear means they're all on the same line. It also goes on to say that point B is in between A and C. So the first thing I would do is draw a line segment. You're going to have 3 points on it. And it really doesn't matter what you make this look like. It doesn't matter where you put that point in the middle, because right now I'm not caring so much about accuracy. I just want to have a picture so I can kind of start drawing in the things that they give me and then use those. So I'm going to call this A and this side C, and I'm going to call this one B. And the reason why I'm putting it that way is because they told me B is in between A and C. So I just know B has to be in between those 2 points somewhere. Okay. Now underneath it here, they give me some information, and I need to take this and maybe put it into my line segment. So it wants me to figure out how long BC is if that segment BC is represented by 2x plus 23 and A to C is x plus 24. So how I'm going to write that one is underneath the line here, I'm going to write x plus 24, and I'm going to draw little lines on either side that kind of show that's going all the way from A to C, and I'm going to have that x plus 24 right there in the middle. And then they also say that AB, so this left-hand side is 9. Questions on how we set that up like that? Okay, once you have your picture drawn, then you can start thinking about how I'm going to set this up to solve for my x. Because just like that last example, I need to figure out what x is, and then I can plug it back in to find my BC. So how would I set this up? We're going to have to add the smaller pieces, right? So we're going to add the 9 plus the 2x plus 23. And what are we setting that equal to? Good. The x plus 24, the whole thing. Okay. And now I'm going to combine like terms. So what can you guys put together? All right. You want to start with the 9 and the 23 together. Good. So 2x plus 32 is equal to x plus 24 over here. All of that just drops down because we can't put those together. Now what? Okay, so with the x's, you could decide, do you want to move the x or do you want to move the 2x? Remember what I said, though, is I like to try to keep x positive if I can. So I'm going to subtract x from both sides. And so this becomes x plus 32 equals that 24. And then what would you do? Yep, subtract that 32. I'm running out of room. So x, if I subtract 32, that would give me what? 24 minus 32 is -8. Good. Are we all done? No. Okay. Is it okay that I got a negative number here for my x? Yeah, it's fine as long as when I go to plug it back in, I don't get a negative answer for my segment BC. Okay, so I'm going to take this -8 here and I'm going to plug it in for the x up here. So we're going to take 2, I'm just going to write that over here, 2 times that -8 and then plus 23. Okay, and then let's evaluate that. So this becomes -16 plus 23. Yeah, it would be 7. So BC is 7. Okay. Can you guys think of a way that you could maybe like check your answer here? What's something that you could maybe do to check your work? Okay, so you know AB is 9, right? BC, we just found that to be 7. But that's not a great color. 7. Okay, what's 9 plus 7? Yeah, 16. Okay, so now come down here. If I plug in -8 to the x here, what's -8 plus 24? Should also be 16, right? Yeah, so if you were checking your work or you wanted to make sure that you solved it for x correctly, that's something that you could do. You just need to plug them in and then compare. And as long as it makes sense, like I'm adding these two smaller pieces, that should be the same thing as the big long one, then we should be able to say that they're going to be equal to each other. Good. Okay, so there's one more here, and I'm going to give you guys a couple minutes. I want you to do this one. Draw a picture, okay, label it, and try to set it up and solve it here. Okay, I'm going to get started here. I'm going to start out by drawing the picture. So you're told that for this one, You've got 4 points this time. It says A, B, C, and D are collinear and positioned in that order. Okay, so A comes first, then B, then C, and it ends with D. Okay, and I'm not going to care right now about accuracy of where you put those points. Like, I'm not necessarily worried about these pictures being drawn to scale, that you have those points placed correctly apart from each other so it makes sense with your numbers. Okay, right now you just need a visual aid. Okay, now let's fill in what we know. So find CD if B to C is 3, A to B is 12x minus 1, C to D is 3x plus 1, and A to D is 18x. All right, so hopefully your picture looked a little something like that. Now for this one, you have a couple of additional pieces here. Like, we had extra letters, which means we have a new part of our segment as well. But this is no different than what we did on the last one. We're going to combine those smaller pieces together, set it equal to the whole thing. So 12x minus 1 plus 3 plus 3x plus 1. And we're setting that all equal to 18x. Okay, on the left-hand side, I would have put the 12x and the 3x together to get 15x. And then I would have combined -1 plus 3 plus 1. And that's just going to come out to be 3 because those ones are going to cancel. Equals your 18x. All right. Then I'm going to move this 15x over here because, again, I like to keep x positive if I can. So I'm going to drop down my 3 equals 18x minus 15x would be 3x. I'm going to divide by 3, and we should have gotten x equals 1. Okay, but what are they asking for? CD. So I got to make sure I take this and plug it back in up here to that 3x plus 1. So 3 times 1 plus 1, yeah, is going to be 4. There you go.
I didn't get that. Could you try again?
Any questions?